Hello and welcome to Mr. Barton's autograph video number 40. Now a few weeks ago we looked at how we can use one of the excellent autograph extras pages. In fact, let's have a look which one it was. The dice simulation page to start to look at probability on autograph. Well, this week we're going to take that one stage further by actually using probability distribution functions, but we don't have to get all complicated and bogged down in A-level maths, and in fact this can be used to introduce experimental probability at key stage 3 or key stage 4. So let's have a look how we do it. First thing, we need to be in statistics mode. Now it doesn't matter if you're in advanced or standard. I happen to be in advanced, but it doesn't matter. And I'm going to hover up here to enter raw data. Now, as we've seen ages ago on these videos, you can paste any data from wherever you like in here. But what you can also do is you can create your own data by using distributions. So I'm going to select a distribution here, and I've got all the ones that we've looked at in the past, but actually I'm going to invent my own little distribution here. So I click OK. And let's have a look what it looks like, edit distribution. Now what you can do here is you can choose the probability of any value starting at 0 and going up in ones of coming up. So what I'm going to do is just do a bog standard dice. So I want the probability of 0 coming up on the dice to be 0. I want the probability of 1 coming up to be a 6th. 2 needs to be a 6th. 3 needs to be a 6th. 6th. 5 and 6, just quick count, 1, 2, 3, 4, 5, 6, there we go. Click OK. So that is going to be my fair dice. If I click OK, now what I can do here is I can roll that dice not just once, not just 10 times, but I'm just going to roll it 100 times. So I'm going to click create sample, and if I just want to sort that data very quickly to have a look at it, there's a load of 1s, there's a load of 2s, loads of 3s, but if I click OK we can actually get this graphed very quickly on autograph. There's my raw data. I'll just bang out a very quick dot plot. Click that, yeah, 1 and 1, that looks fine to me, click OK, and there you go. So I've rolled it 100 times, and the students may start to think, oh, it looks a bit biased this dice, maybe 3's coming up a little bit too often, but if we roll it a few more times we may see that it's not actually that biased. If I just double click on raw data again, I'm just going to clear that data, and instead of rolling 100 times I'm going to go 1,000. Now you know what, let's go 10,000 times. Create sample, look how quick autograph does it. Click OK. We're off the scale, not a problem. Let's just auto scale that, and there we see that that's looking pretty uniform. But that's boring because that's just a fair dice. Let's mess this dice up a little bit. So if I double click on raw data, I can now again go to edit distribution, and this time let's make, say, the probability of getting a 1, let's go for a 12th. And that freezes up, I think, an extra 12th. So let's go the probability of getting a 6th as 3/12. Now I hope my math is right there, and that still adds up to 1. So click OK. Now if I clear all my data again, and this time again I'm going to take 10,000, so let's create a sample, let's click OK, and that should automatically update. If I click auto scale, we'll see, yeah, there we go, 1's not popping up quite as much there, and 6 is popping up a fair bit. And it's quite good if you set that up prior to the lesson, you can challenge the students to think what the probabilities were on that dice. And I'll show you another thing you can do that works quite well. Is the old classic number of balls in a bag. So if I give this a little click, and again I go to my edit distribution, and I'll just delete that to there. Now imagine you've got a bag of 10 balls and they're numbered, say, 1, 2 and 3, let's say, for example, and say you've got 2 of the 10 balls are labelled number 1, 4 of the 10 balls are labelled number 2, and what will be left there, 4 of the 10 balls are labelled number 3. And there you've got a very simple probability distribution function. So 4/10, 4/10 and 2/10, click OK. I'll clear my data again. And if I pick these balls out of the bag, let's say 100 times, there's my sample, click OK. Now that's obviously messed up a little bit, but if autograph can sort that out, and if I just move along there slightly, again I can challenge the students to say, okay, I've picked 100 balls out of that bag and looked at them, that's what's come out, how many of each ball do you reckon were in the bag? And that leads us nicely into experimental probability. So hope that was useful, and I'll be back with a brand new fresh video next week. Bye for now.